Okay, how's it going, guys? Today we're gonna go over this really special problem that used to bother me a lot when I was young. It is called the Monty Hall problem. I think this is called Monty Hall problem. Um, and something like this. You're in a game show. Like let's say this is you. Yeah, you're in a game show, and in this game show, you're presented with three doors, right? In one of the doors, there's two goats. Let's say goats. Um, oh, I'm sorry. There's a mistake there. Um, um, there's there's there. So in one of the doors, there's a car, and the in the other two doors is a goat. Right. So you can have yeah. Um, yeah. So in one of the doors is a car, and the other two doors is a goat. Um, Suppose that you pick one of the door, okay? Uh, but before you open the door, right? The host, I think his name is Monty, say open another door, and that door has the goat, right? Um, the question is, should you switch, right? Um, and the answer is you should switch because the probability of switching um, and getting a car is higher than not switching. And yeah, so so you have three doors. Behind one of the doors is a car. The other two doors behind the other two doors you have goats. And just as when you're about to open one of the door, Monty the host opened one of the door and and behind one of the door is a goat. The question is, should you be switching? And the answer is yes, you should switch. So I want you guys to try to solve this problem. You can pause here if you want. Okay, so let's try to solve this problem together. Okay, so suppose that you know in door one, you have the goat, and door two, you have the goat, and door three, you have the car. Right. So door one you have the goat, door two you have the goat, door three you have the car. Suppose that you on your first um move. Suppose that on the first pick, you pick door one, right? You pick door one, and he has the goat, right? But then Monty opens the door that has the goat, namely D2. So you'd be switching. So if you are in door one, right, uh, then you are up, behind that door is a goat, right? But you don't know if you have a goat or not, right? So Monty, the host, open door two and show you that, oh, there's a goat behind door two. So now the question is, should you be switching? Obviously, from a guy's eye perspective, of course you should be switching. You should be switching to door three, right, where the car is in door three. So yes. So if you open door one, yes, you should switch. Suppose that you open on the first draw, you open door two, right? Door two. Um, then Monty opened the door that has to go. Namely, in this case, it's going to be door one, right? Um, so you switch. Of course, you should switch because if you're in door two and Monty opened door one and show you the go, of course you should be switching because the car is in door 3. So again, yes. Now suppose that you open door 3, right? But if you open door 3, Monty could could randomly open one of the doors, door 1 or door 2. Let's say Monty opened door 2, right, and show you the go. Should you switch? No, of course not, because the car is in door 3, the one that you actually picked. So if you switch, you're gonna get a gold, right? So no. So it seems like you have, so in all 3 possibilities, right, switching leads to getting a car, right? If you open door 1, you should switch because you're gonna get a car. If you open door 2, you should switch because you're gonna get a car. If you open door 3, you should not switch. You're gonna get a go. So the probability of getting the car is 2/3. So this is a very fun problem. It's a problem that, when I was young, it bothers me a lot. But with a little bit of reasoning and creative labeling, this is actually a pretty simple problem. All right, thank you so much.